I'm CK. We haven't done a digital clock kit in a while, and I found a company called Banria, who I have done one kit from, but they have a number of kits, slightly different than other ones we built, so I wanted to explore it. This is their 4-digit digital alarm clock with RGB colorful digits, so that'll be kind of fun. We'll put it together, see how it goes together. It probably has an annoying case, but I'm used to that by now. And hope we have fun with it. And I hope you enjoy the video. The box, picked it up from Amazon. See what's inside. Plastic bag, case pieces. Oh good, this case may actually be easy. And we'll get the box ready for recycling. Let's look at the case first, because this looks like, again, I will be excited because it's an easy case. Oh yeah, very nice. Actually, this is a nice case. This is well made. Oh, look at that. So it's not going to show the entire segment unless we're going to put it together a little differently than I think. But we'll figure that out when we get there. But it's a well-made case. I'm looking to see. No, it's not actually. I thought it might be 3D printed, but it is molded. But they also ran a finishing tool along it to smooth it all out. They put more effort into this case than most people put in their whole kits. That's pretty nice. Now we'll open this bag up, and I gotta cut this open. Colorful RGB clock kit. Let's look at the circuit board first. If I can get the circuit board out. Up, circuit board. It's got, oh, look at that. Oh, okay. So, I was wondering how this was going to be, because I thought this would be a multi-segment display. It's not a multi-segment display. You'll see on the circuit board, we've got 2 surface mount controllers, and then a bunch of surface mount LEDs installed. And those LEDs are what are going to poke through these little holes in the case and show through in the front. It looks like you can see the outline of, I hope you can see, outline of what would be a multifunction display. It may have some light piping in there to smooth it all out. So that's interesting. Then on the back we've got, looks like we've got a backup battery here so we don't lose the time when we unplug it. We've got a bunch of resistors, transistor here. Not sure where the control switches are. Oh, switches are down here. Then we've got another chip that's going in here. That's a DS1302N. I don't know what that is. Then we've got a 32 kilohertz crystal. A couple of disc capacitors, looks like. Another disc capacitor. A connector for USB in, I believe. Double check. I'll figure that out when we get to it. There's 2 pads here. I don't know what they may do. They may be, I think they're heat sinks under the chips, but I'm not certain. Then we've got another chip here, an STC chip, so that's a microcontroller. So these may be the LED, these are the LED drivers. That's what these 2 chips are. Because as you can see, there's traces going out to all the LEDs from in here. So that's all going to be relatively straightforward. Here's the USB, where the USB connector will be. Not a ton to solder, but certainly enough to make it interesting. And look, they gave us a little screwdriver to put the case together with. Well, that's thoughtful of them. Here's the piece of paper. This product comes to you is DIY kit that needs to be installed. Yep. And then we've got an installation manual PDF if we want. Oh, it shows you how to set it in big letters. I like that because I always get confused. And here's all the things you can do with it. Too complicated. Too complicated. Too complicated. So this is all just set up. This is not assembly. So here's the schematic. And I'll have to look at that's the 1350. This is the microcontroller, which is going out to, see, they don't show the, we've got clock 1, data 1, and data 2, which are coming out of, where are they going to? Oh, they're coming out of the microcontroller. Here, there's clock 1, data 1, and so on. So we do, well, we kind of need the build guide, but really, not really. I should talk about that more in a second. So we've got USB power connector, little battery to put in the backup battery slot. And we've got all the componentry. I have to look up this. The 1320 is probably the actual clock. Oh, we've got a little photoresistor to dim or light the display up. Then here's the, again, I believe that's the clock chip. 1302. Let me look on the schematic again. So the 1302 has power coming in. And then, oh yeah, it's got its clock signal coming out, and that's going to S clock, which is coming in here to the microcontroller. That's where it's going to be reading that, and it's got a reset. Okay, got a couple of resistors right there. Little tactile switches to do clock setting and so on. One of the ubiquitous little buzzers that people use in all kinds of things. Some caps to put on the buttons. Here's our 32 kilohertz clock crystal. Here is, oh okay, it must have temperature. Here's a thermistor to sense the temperature. There's our 3 disc caps and our 1 transistor. What does the transistor do? Transistor, oh, the transistor is to buzz the buzzer. Switch the buzzer, input power on, off, on, off, on, off, on, off to make it buzz. And some screws. So, again, looks pretty straightforward. Let me take a look, because I don't think I need the build guide. I'll probably bring it up just for reference. So I think the LDR here is the light detecting resistor. That's this little dingus, which would make this NTC normal temperature chip. That's what I'm making that up. But I think that's where the temperature sensor will go in. Then when this goes all together, let me get this right. Yeah, because you're going to have the light sensor, which goes here, is going to poke through this top hole. Oh, that's too bad, that's a little scratched. And the thermistor, the temperature sensor, is going to go through this hole. So that's all pretty straightforward. This is going to be pretty straightforward kit to build. I'm feeling this to see if the LEDs seat right. Oh yeah, it seats just fine. Good. Okay, that's all good. I will get the soldering iron heated up and we'll start putting this fella together. I'll bring the assembly instructions up just so we can all take a look at them. Back in a bit. I pulled up the build guide. It's not detailed. but it does have a picture of all the components in their correct places when you're done, which is all good, and that really is all we need to see. So we'll go ahead and put this together. Got a couple of things we're going to be paying attention to, like how much we want the sensors to poke out of the top of the device, and we'll get there. But first, I'm going to put the resistors on, and they are all 10K. There are 3 of them, and they're 10K, so that will be easy to get right. So first thing we're going to do, actually there are 4. There are 4? I think they gave us an extra. They did give us an extra. That happens frequently in kits, as I've found over the years, is they may give you extra resistors. Often they'll give you extra LEDs if they include LEDs, and it's just nice to have. And the extras you toss in to make a little bin or box or drawer for yourself, or can that contains all the spare things you get as you build, because you may very well find them handy in the future. It's a good way to start building up your bench stock of stuff. So let's see how the how the circuit board takes solder today. Oh, perfectly. The only challenge being, and this is only my personal feeling, it has nothing to do with the quality of the board or the effectiveness, but these white circuit boards, they just leave an unsightly little brown spot where the rosin pooled as you're soldering. Now obviously you could clean all the rosin flux off when you're done. I will admit I rarely do that. So there's the resistors. Now I will put the disc caps on. There are a couple of 22 picofarads that go down here, which seem to be conditioning the crystal. I think, yep, seem to be conditioning the crystal. These are labeled as 2-2. Then I'll put the 100 nanofarad, which is this 104. You'll see these often around chips. Oh, by the way, I didn't actually look that up. Let me do that real quick and let you know. So the DS1320 is a trickle charge timekeeping chip. Very low power. I remember this. No, I don't want your stupid cookies. Oh gosh darn it, where did it go? Oh, this stupid thing. So again, this is the clock chip, and it's very low power. I think it's in the microamp range. So there's the other 104, and we've got a 10 that I don't know where this goes. Oh, that's another 100 nanofarad. This must be another 104. We have 2 chips on the board, this one and this one, both taking 104 capacitors, which are typically decoupling caps to condition the power going into the chip a little bit. Oh, I bent that up so much it got wacky on me. So I'm not going to solder those right yet. I'm going to do the sockets and then the caps at the same time. So you'll notice there's a little notch cut out in the socket, and there's a little notch cut out printed on the circuit board, so you know how to arrange this correctly. And what I'm going to do is I'm going to rest it on my, where is my solder? I'm going to rest it on my pinky finger firmly and solder one pin so that's securely on there, so I can get the other one on. The other one goes down here, and the notch goes up on this one. I mean, my up. Now I'll solder all these connections that I've been making. So they are all securely affixed. Let's see what else we've got here. I'm going to put the timing crystal on here. Right here. They have a pad. I don't know why they have a pad there. I guess you could. It doesn't have any traces coming off of it. I think it's simply to allow you to solder it in place if you want, so it doesn't flop around. I'm not going to do that. So put it in. Don't push it all the way flat, because then we're going to just lay it down like that. I'm going to put the buzzer on at the same time since I'm working on this end. Now this is polarized. It's got a plus sign on it, and there's a plus sign on the printing on the board. So we want to make sure those match. And we'll solder those two things we just put on. And then lay that flat again. Again, I could solder the case of that down, but it's not necessary. And since it's going to be inside another case, I'm not going to do that. I'm going to put the switches on now. Got a little out the side. Actually, since these have support legs, I'm just going to leave them for a minute because I don't need to do anything with them yet because they'll stay in place. And we'll put the transistor, which buzzes the speaker. And it's got a flat side, and there's a flat side printed on the circuit board that tells you how it goes. And I guess I'll do the button battery too right now. Actually, I'm going to see if the USB connector fits on well. Oops. Golly. So this is almost surface mounty, but not too bad. Just leave it flat like that. Get your solder. And that will be fine. We'll do the support legs. You always want to do the support legs on your power connector because they take the force of you plugging and unplugging the connector, and you don't want it just to rely on the power connections themselves because they're not as strong as the support lugs. Now we're getting all the switches, and same with the switches. They've got two support legs on them too. Now all we have left are putting the chips in. Oh, we've got the battery connector. I'm sorry. Now you want to put the battery connector in here. There's an outline on the board that matches the shape of the battery connector. You don't want to get it backwards because if you get it backwards it's going to be more of a pain to change the battery if you ever need to. I mean, the likelihood that you'll change the battery in this thing is pretty dang low, I will admit. I don't know why this is giving me fits. There we go. The likelihood that you'll change the battery is very low, but we'll put it on there anyway. Of course, I have whole house batteries. I have two Tesla batteries supplying backup power to my whole house, so I don't worry about power outages anymore. Now, I'm going to want to... Oh, there goes my stupid water heater. I'll be back in a little bit. Water heater's back off so you can hear me talking again. And now I've set the circuit board in the case because I want to get the right length. Golly, where's my black marker? I want to get the right length for how far the temperature sensor and the light detecting resistor are in. So I want having done this before, I want the temperature sensor to be about there, because I want it outside of the case in case, in the event of any heat building up in here from the LEDs. And it's going to chimney up there anyway, but at least that 1/2 inch, 3/8 of an inch will be fine. So I marked the legs with a little black from this marker. And then the light detector, I can go right up to the opening. So I can go pretty much flush with the opening on that. So I'll mark my leads with the marker again, put the marker away, so it's there the next time I need it. Pull this back out. Now I'll put this one in its spot, go down to, of course I put it backwards so I can't see the lines I made, push it down to where little black lines I made are, and bend it over, and that will be where that goes. And I'm going to solder that right now so it doesn't creep around on me. If I can find a piece of solder. Now I'll do the same thing for the resistor. Bend that right, basically right at those black lines, maybe a little bit off. And I'll be doing a little twisting and tweaking as we put it in the case anyway. Yep. Now it did slide out. It slid out. I don't want that. So I'll reheat the solder and push it up with my thumb. Of course the wire gets hot, but I don't care. I burn myself all the time soldering. I don't even notice. Now I'll trim those leads. What do we have left to do? We've got the battery to slide in. And typically, the plus side goes up, like so. Now I'm going to put the button caps. Actually, I'm not going to put the button caps on quite this second because I want to make sure that I can get them on after I put it in the case. Oh yeah, that'll be fine. Now I'll just press the button caps on the buttons, and I'm going to support the button body as I do that. Do the other one. So they'll go in there like that. Now, as you may have noticed, I didn't put the ICs in yet because I'm still checking it out. So that's all the assembly done for this part. Now we'll put the ICs in their sockets. First we'll put the microcontroller in, which is going to take the signals from the clock and convert it into information that the LED drivers can work with, and notch to notch, of course. And it also does the interpretation of the input from the temperature sensor and the light receiving resistor. I grew up calling them photoresistors, and I'm going to keep calling them photoresistors. And I think I might have bent that one in a little. Nope, got it in just right. Okay, so that is the two ICs installed. Now we can actually put it in the case. And again, thread my 2 external components out the top. Now we've got 4 screws to go in the, hold the circuit board on. Oh, for crying out loud! I was thinking logically, and I should be thinking kit-wise. These corner screws are these ones I've been fighting with here. Because I think it does have the right amount of screws if you put it together right, but I did not expect that. I thought the circuit board securing screws would be inside the case and not keeping you from opening the case. So that means whenever you open the case, you're going to be breaking the circuit board loose too. So if you ever do build this and want to do that and ever have to take it apart to change the battery, well, then you're going to have to remember when you take it apart, the circuit board starts floating around free also. Again, I'm not a big fan of that, which is why I didn't think of that, and actually instead of not enough screws, now we've got 1 extra. So there it is. Let me wipe my fingerprints off the front here. Next thing I'm going to do is turn off my overhead lights so we can get a little bit of contrast on this. And now I will get the power cord. And it's a micro USB or mini USB or whatever. I can never keep track of that, which is why I'm so happy that we all basically have moving to USB-C. Everything will be easier. I'm actually going to switch. I'm going to not use the cable they supplied. I'm going to use one that I have on my desktop here. So let's plug this in, and it should power up. I can get the connector right. And there it goes. Beep, 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 cycling through. 759. Look at that. That's pretty. Oh, the colors are washed out. The colors... Yes, yes, thank you. Thank you. Thank you for making beepy beepies. Now shut up. The colors are much more vibrant than are showing on my camera. I'm not quite sure why the camera is dulling them out, but now, let's see. Let's see if we can color display. Set time mode. We're going to do that first. Well, I don't know what I'm doing here. So there's the time. Okay, we're going to make the assumption that this is now the time. So it's flicking between what it thinks is the date or time and the temperature, which is what I want. But now press, set time mode, press the up switch for more than 2 seconds. Okay, not the other switch. Okay, so it's not 2023, 2024, there we go. Now it is April something or other. April I know you're going to see this in like July, but I'm doing this in April. Oops. April 18. Okay, and now we're doing the actual time. Okay. Whew, that took too long. Took us all the way to 12:33. Okay, so that's right up. I did it wrong. Now I got to do it again. That's, oops. Golly, I keep messing up because they reversed the buttons on me. So I've got the year up, got before. Got the year wrong. We'll go in 24-hour clock. And then there's an error factor, a correction for adding seconds per day, but we're not going to do that. So that's what it does. There we are after much fiddling around with these single presses. So as you'll see, it flicks between time and date, and as it flicks, you'll notice that the temperature, or you hopefully can notice, the colors are changing at random. It looks like it's actually stepping through colors instead of being actually random, but I'm not going to complain about that too much. And I'm sorry, the display mode is driving me a little crazy. I don't want it to flick. Okay, so that is set up, but now I got to get out of this. There we go. Okay, whew! After all that, now it's just going to sit there showing me the time. And that's all I really wanted. So after all that, the case was a little fiddly because I made an assumption about how the circuit board would come in, and that's my fault. I could have looked at it a little more closely to get that correct. But in general, this is a good kit. It's, look, the minute changed, so it randomly changed the minute color. And that's what we'll be seeing. And I'm going to put this somewhere. I have a place for this, and I'll figure it out. Not a bad clock. Again, it's just all these hundreds of different options to set with different button presses is a little frustrating, but that's okay. Overall, a very good kit, and I'll be getting some more from this company. And I hope you enjoyed the video.